Okay, so we're going to do another problem that looks at circular motion. So in this case, we have a train traveling at a constant speed around a curve of radius 215 meters. A lamp suspended from the ceiling swings out an angle 16.5 degrees throughout the curve. What is the speed of the train? So the train's going in a circular path. It's going around a curve, which is part of a circle. That's what I drew here, of radius r, capital R. Our centripetal acceleration is going to point towards the center of the circle. Now, inside this train, maybe in a little department or something, let's do, so inside, I'll do it, I guess, right here. Inside we have a, we'll do that in black, and then I guess blue. I like blue. We have some lamp here. I'm just going to draw it as a little box. We'll give this an angle theta. Okay? Now let's draw a free body diagram for that lamp. Let's start with the easy one. We have gravity. We also have this tension force, which is going to have components. This is that angle theta. We have tension in the y direction, which is just going to be t cosine theta. And we have tension in the x direction, which is going to be t sine theta. I'm going to use a slightly different notation than x and y, but I'll show you what I mean when I get there. So there's our free body diagram. We drew all our pictures. That's really what we want. The way that I'm going to denounce the components, orange is fine, is I'm going to talk about centripetal. Well, let's do that first. So the sum of all our forces seeking the center, or center seeking, is equal to mass times our centripetal acceleration. Now the question is, which part of our force is related to this centripetal acceleration? Well, not gravity, right? And not the y component of tension. It would be the x component. This is the force that's causing our acceleration towards the center. So we would say t sine theta equals mv squared over r, because if we don't remember, one of our equations is centripetal acceleration is equal to v squared over r. And all I did was I substituted this into here. Okay? Well, that's great, but we don't know what tension is. So let's do, what color? I guess green. We'll do the sum of all forces in the y direction is mass times acceleration in the y direction. And these are the other forces. These are the forces that are perpendicular to our acceleration. Now this is 0 because the lamp's not bouncing up and down. So what do we have? We have t cosine theta minus mg equals 0. And now you can see we can solve for tension here. Tension equals mg divided by cosine theta. Let's box all this. So we did Newton's second law. This was Newton's second law. Now we need to combine them. So I can take this tension and plug it into here. And what will I get? Mg, sine over cosine is tangent theta. equals mv squared over r. And as a reoccurring theme, we see the masses drop. That's why I said not to be too worried if you don't know the mass. A lot of times it ends up canceling. Solving our gravity times our radius times tangent of theta, that's my dog playing with his toy if you hear it, is equal to the velocity. Let's plug these numbers in. That's 9.81 times the radius, which was 215, times tangent of the angle, which is 16.5. This was all given in the question. And you get about 25 meters per second. So let's like that color. And that's it. So we drew some pictures, some free body diagram. We utilized Newton's second law. We learned what we knew about centripetal acceleration, and then we're just solving an algebra problem. So if you can get the physics done, the algebra's not too bad in this case. But sometimes students struggled setting the problem up. So hopefully this helps a little bit, and I think next we're going to do an exam review.